Europa, one of Jupiter's 79 satellites, slightly smaller than our moon, is officially the best candidate in the solar system to host life forms. At first glance, it seems just a cold and icy moon 800 million kilometers from the sun, much farther than Mars, and with few offerings, except for a fantastic view of the gas giant Jupiter. However, beneath that thick layer of ice hides a vast liquid ocean that should have all the necessary conditions for life. And an important confirmation of this came a few months ago from the James Webb Telescope. Scientists began to take interest in this world for the search for extraterrestrial life not many years ago, after NASA's Galileo probe measured disturbances in Jupiter's magnetic field near Europa while orbiting the gas giant between 1995 and 2003. The measurements suggested to scientists that an electrically conductive fluid, probably a salty ocean beneath Europa's ice, was causing the magnetic distortions. When researchers examined the magnetic disturbances more closely in 2018, they found evidence of possible water plumes. A year later, in 2019, this was confirmed by an international research team that detected water vapor for the first time above Europa's surface through one of the world's largest telescopes in Hawaii. Obviously, the confirmation of liquid water does not imply the presence of life forms, but a significant step that greatly increases the chances of finding life forms has been taken thanks to the James Webb Telescope, with an infrared observation instrument that can provide information on the presence of chemical substances on a celestial body by analyzing the light that arrives at various wavelengths. And with this method, the presence of CO2, one of the fundamental elements for the origin of life, has been found in just a few minutes of analysis. It is considered by most of the scientific community as an essential element for the development of life. In fact, all life as we know it today is based on this important molecule. Carbon has been found in a particular area of Europa called the Terra region, a very rugged and disconnected region, slightly depressed compared to the surrounding areas. It is a geologically young area. It has formed recently and is therefore a emerged terrain known as chaos terrain. In this area, the surface ice has been destroyed, and there has probably been an exchange of material between the underground ocean and the icy surface. Confirmation of this is given by the fact that carbon dioxide is not stable on Europa's surface, so it is unlikely to come from external events such as the fall of a comet. Its supply must be continuous over geologically long times, which leads to an origin from inside the ocean of liquid water under the crust and then transported to the surface by cryogeological phenomena. This is also very important for oxygen, another of the fundamental molecules for life. Certainly, there could be life forms without oxygen. Even on Earth, life began this way, but at the same time, the presence of oxygen would greatly increase the chances because it allows you to do much more energetic things. We know that on Europa, surface oxygen tend to form due to the continued interaction with sunlight. So particles coming from the sun and particles from Jupiter's magnetic field hit the ice, breaking up H2O molecules and thus releasing oxygen. And precisely thanks to cryogeological phenomena, oxygen would be transported to the underlying ocean, creating perfect conditions for life. Personally, I believe that after this discovery, Europa has become by far the best candidate to host extraterrestrial life in the solar system. And precisely for this reason, the Europa Clipper mission by NASA will start in October of this year, carrying on board many instruments to study this moon up close and prepare for a future mission in which we will land with a lander on the icy surface. This mission will have a camera capable of taking high-resolution color photos of Europa's surface, and they will be the most detailed photos ever of Europa. There will then be an infrared imaging system to distinguish between warmer and colder areas, thanks to which we will understand which are the areas where the ocean is closest to the surface. There will also be an ultraviolet spectrometer that will map the distribution of atmospheric gases and materials on the surface. thus giving us other important data on the substances of which this world is made. This mission, together with the ESA's JUICE mission, will arrive at its destination after a long journey of 7 years and will probably give us an answer to many of the doubts we still have about Europa today, and it will be another important step towards the search for extraterrestrial life.